Let the function q, where q of x equals x times 4 minus x. A rectangle ABCD is inscribed between the graph of the function q and the x-axis. Its vertices are a units, where a is larger than 0, from the axis of symmetry, x is equal to 2, as shown below. Find the value of a when the rectangle is a square. Give your answer in the form b plus root c, where b is an integer and c is a positive integer. We're told that the vertices of the rectangle ABCD is a units from the axis of symmetry, which means that these lengths are going to be a units each. If this rectangle is a square, then this means that the width of this rectangle is also going to equal 2a. The width of this rectangle is going to be the y-coordinate of the function q of x when x is equal to 2 minus a. And so we can state that 2a has to equal q of 2 minus a. Q of 2 minus a is going to be 2 minus a times 4 minus 2 minus a. And so wherever there's an x, we'll replace it with 2 minus a. And so this is going to be 2 minus a times 4 minus 2 plus a. Simplifying this will be 2 minus a times 2 plus a. Expanding this is going to be 4 minus a squared. And so therefore we could say that 2a is equal to 4 minus a squared. Rearranging this, we're going to get a squared plus 2a minus 4 is equal to 0. We now have a polynomial which we need to solve for a. To solve for a, we need to complete the square. And so we can write this as a squared plus 2a and then plus 1 minus 1 and minus 4 is going to equal 0. Factorizing this, we're going to get a plus 1 squared minus 5 is equal to 0. And so a plus 1 squared is going to equal 5, which means a plus 1 is equal to plus or minus root 5. And solving for a, this is going to be minus 1 plus or minus root 5. We're told that a is larger than 0. And since a is larger than 0, then this means that a can only be minus 1 plus root 5 in the form required. Find the maximum area of the rectangle ABCD. Give your answer in the form m times root n over p, where m, n and p are positive integers. To find the maximum area of the rectangle, we start by writing an equation for its area in terms of one variable. The area of the rectangle is found by its length times its width. We know that the length is 2a, and its width in terms of a is going to be 4 minus a squared. And so we can write the area of the rectangle as 2a times 4 minus a squared, which is equal to 8a minus 2a cubed. To find the maximum area, we need to find the derivative of a, let it equal 0, and then solve for small a. And so we need to find a dash of a and let it equal 0. A dash of a is equal to 8 minus 6a squared. And so if we let this equal to 0, we're going to get 8 minus 6a squared is equal to 0. And so 8 is going to equal 6a squared, which means a squared is equal to 8 on 6, which is the same as 4 on 3. And so a is going to equal the square root of 4 on 3. And since a is a positive, we only want the positive square root. And so this is going to be 2 on square root of 3. And now rationalizing the denominator, we multiply by root 3 on root 3, which means a is equal to 2 root 3 on 3. And so when a is equal to 2 root 3 on 3, the area of the rectangle is going to be a maximum. To find this maximum area, we need to evaluate a of 2 root 3 on 3. And so this is going to be 2 times 2 root 3 on 3 times 4 minus 2 root 3 on 3 squared. And so this is going to be 4 root 3 on 3 times 4 minus 4 times 3 over 9. And so this is going to be 4 root 3 on 3 times 4 minus 12 on 9. We can write 4 as 36 on 9. And so this is going to be 4 root 3 on 3 times 36 minus 12 is 24, and then divide by 9. From here we can cancel out the 3 and the 24, and so this is going to be 8, and so this is equal to 32 root 3 on 9. And so the maximum area is going to be 32 times root 3 on 9 square units in the form required. If you want to practice various exam-style minimum and maximum application questions, then log into the Maths Methods Club, and then from the main topic select differentiation. And then from the subtopics select maximum and minimum values. Go through these questions, as it will help you to approach minimum and maximum application questions confidently and help you to ace your SACs and exams. Good luck, and I'll see you guys in the next video.